whatever time is for you
You
joining us.
stole my line.
I stole your line, You can try the same
Yeah.
thing. So today we are lucky to have Catalin Gheorghiu joining us, and as you can see, it's his nighttime. Of course, we are.
No, I have a very dark office.
We
This
are
is
fortunate
true.
to have him. Thank you. If you have any questions during the session, just feel free to write your question in the chat box in the YouTube page you are watching this right now, and we will be working on those questions and answering those questions later at the end of the session. So here you go, Catalin. Please introduce yourself and start sharing your screen.
Okay. First, thank you, Rada, for the opportunity to um, speak to that huge, huge, hopefully, audience channel. So let's share my screen. That will be something at the beginning quite bland. We'll start of a presentation. Uh, so, Rada stole my line, but hello. Hello, wherever and whatever you are. Let's say, I will try to do a presentation that will make, let's say, some sense. I'm trying here also to show you hardware, and for this, you will need quite a special setup. Let's say better than Hanselman's and more like Adam Savage. As you see by lightning, because it's a bit dark, not even the lightning, I wasn't able to get it to the good level. But still, I believe that you'll get enough information to get you started. Think this presentation like the sand in the pearl shell. I'm gonna put that grain of sand and get you curious to look around and maybe do something. Okay, let's introduce myself. I'm Catalin Gheorghiu. I'm coming from Romania. I'm a CTO to a small company that we work in IoT even before IoT had a name. So we do a lot of stuff in hardware. We're mostly in Microsoft stack. Also, we do a lot of hardware. As qualification, you see from the slide, from 2011, Microsoft each year awarded me the title of Most Valuable Professional. I'm in two categories, Windows development and Azure. Intel awarded me the title of Intel Software Innovator and also a Microsoft Certified Trainer. So, to set your expectation, this will be more or less a development session. If you are a data scientist, here you won't find more information how you can create a model or stuff like this. No, it's more targeted of you being an architect or a developer trying to solve a solution and how to use fast, smart, and elegant computer vision. And in this presentation, the accent will be to OpenVINO from Intel. But how we got to this presentation? Now, this started from a project that we had at work. Okay, I'm always, if there are any Romanians we're gonna listen to this presentation now or later, I am always, they always complain that I'm using Romanian stereotypes, that the Romanian worker, okay, let's just say the problem. There is a company manufacturing something, and they want to be sure that the worker puts the right number of screws and the right kind of screws. And this was the problem that they had. They happened to have less screws or the wrong screws. Somebody was far more powerful than smart. And what would be the, let's say, the normal approach? The normal approach on this solution will be to take a weight counter and to put the analog digital converter to get to a very precise weight of the screws. Analog digital converter takes a lot of processor cycles to get a good value. And also it could happen that a number of screws of one kind to have the same weight like another number of screws of different kind. So it wasn't that secure. But anyhow, for us it was, let's say, a run-of-the-mill project, let's do it. But we started playing with computer vision. So our idea was, okay, let's maybe put a camera and train a model and use this in conjunction with the weight counter to ensure that the right number of screws are put in. And also, we did not get paid more for this. So we started learning. First, we wanted to see what everything we can use. So for this, let's see. For this, we have used run computer vision on a Raspberry Pi with the Raspberry Pi camera. This is a Raspberry Pi 2. This means that also has the Wi-Fi module. So this was the test rig. Whatever I'm going to talk in this presentation, we tested on this rig. Also, usually in my presentation, I really love live presentation. This one, without any feedback, it's not my, first my forte and second my love. I will ask you for a chocolate. What is wrong with this camera? Okay, I will tell you this is an analog. What we have used really for test, it's already bits and pieces. So I've recreated the test rig to show at the conference. So let's share again. Let's get back to a focal point. Let's be this. We started learning what's computer vision. And now we're going to run you through a couple of concepts that are around and talk about our journey on which it took us to OpenVINO. So now I'm going to share something else. So, let's see. It's not a good one, but this one. So this is a site that you gathered. It's a very nice explanation, representation of what were some terms that are used in artificial intelligence, machine learning, computer vision. So it's classification, localization, detection and segmentation. Classification, I know there is an ln. Localization, I know where it is. Detection, I find an ln and somebody else in a picture. And segmentation, I can show you exactly where it is. In our case, we need something like a tree of them. I believe that we need detection and localization, and also to count. We've used it as a model kind, Tensorflow. So Tensorflow, it's from Google. You find it. You find a lot of stuff on the web if you are looking for it. Okay, as validation of our idea, because we discovered a company from Slovenia, which is doing this. Aribada Penguin monitoring platform. What in the earth is that? It's a Raspberry Pi put in a very smart box, which is saying, I believe, okay, this will be also a question, at the North Pole or the South Pole? I will let this for you in the comments, where it is. And each day, this Raspberry Pi, let's say each 24 hours, because each day at the poles it has a different meaning, wakes up, takes a picture, counts all the penguins, and send it to Lacuna Space LoRaWAN gateway. Okay, as a concept goal, we have a Raspberry Pi, we have the camera, we have a very low consumption Raspberry Pi. This is their trade secrets, whatever. But as a concept, it's similar. And you heard about Lacuna Space LoRaWAN. What in the earth is that? It's a network of satellites having LoRaWAN hotspots. And they are in a low orbit, and they have a pretty good coverage. So, yeah, pretty smart solution. We're doing pretty much that we want. Okay, it's an absolute overkill for this, but it's absolutely working. So we are not doing science fiction, even though up to a point we are bleeding edge using in technology. If you hear some meowing, yes, it's true. The tomcats are advertising that are the best tomcats around. It will remain on YouTube for posterity. So, moving forward, we have discovered that we can run on TensorFlow on Raspberry Pi as it is. So TensorFlow model, no problem. You have all the information how to do this. One of the problems that we have it's that okay, Raspberry Pi, it's not that much of the machine, but we knew it. Okay, for our case, we'll could perform flawlessly, but that's another story. Moving forward. Yeah, we can do also deep learning on it. Raspberry Pi will handle wonderfully. Still, we had a problem to solve. We needed to count, and we found the GitHub for counting how many screws are on a picture. Okay, up to now, yes, we are on the edge, but we're not on the edge. It's not that interesting, but still, bear with me. We'll get there. So, if we want to run a computer vision solution, these are the steps. Again, from the side that we've seen it before, we need to have some images. We need to have an annotator. Yes, you can do some pre-processing. We need to train the model, and afterwards send the model and do all the operation. For training the models, the LabelImg tool is the, let's say, the most common one, but we hate it from our guts. So let's say, here there is I believe that there is a IVS cloud. Amazon is offering a service in which they human will label your images. You need just to pay. We dislike massively this tool of LabelImg. We use cognitive services to do this, and also train model. Again, it was a lot more as computer power and all the stuff. Okay, I'm not gonna show you this because this is pretty much click, 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 click. Getting back, now we're starting to get on the edge. You can run cognitive services on Azure IoT Edge. What is the Azure IoT Edge? It's a number of Docker containers running on some hardware on the edge. By some hardware, strangely enough, it could be even Raspberry Pi. It works okay-ish on Raspberry Pi, but always on Raspbian, because there is a problem running it on Windows. Okay, still it's good enough. It works on Raspbian. What's Azure IoT Edge at the end of the day? It's a number of more than 2 containers running, Docker containers running the cloud. What are those containers? One is an Azure IoT Hub running. The other one is a container enabling communication between all the other containers, and I can deploy whatever else I want. And one of the ideas is to run cognitive services. This stuff, it's pretty much working. The only problem is that we are gathering megabytes here. Yes, these Docker containers are optimized for IoT, so are technically and practically smaller. They are in 100 megabytes dimensions, but still they are pretty heavy. What will be an advantage to this? Like any Docker deployment, you do not care about the hardware. You just run it. But you need a beefy hardware, and you need quite a lot of stuff to transfer. As an additional advantage, the pictures that you run through this cognitive service could retrain the model in the cloud if you have the modification. There is a communication, there is a feedback, that there is something. Again, on the right solution, it will be a right idea. Also, I have heard people that say, okay, the 5G, yes, that dangerous 5G will enable running this almost, okay, I won't say real time, but fast. Anyhow, whatever you are talking about cloud, as it is today, regardless of the provider, you could not talk about real time because it's an architecture based on queues. So queues, by definition, it's not real time. It's very fast, but it's not real time. Okay, we move forward. To make a long story, there is a company in my hometown, I'm from Romania, I'm from Timișoara, which was bought by Intel some time ago. And they are building, this is how they show you on Raspberry Pi. This. We'll see it later. We'll see it later in action. We'll see it later how it is. Let's say a story, the one that I used for demos, I wasn't able to get from the local office. And also, I'm the only one from this town doing presentation about neural compute stick, because they are far too busy developing it to evangelize it. Okay, what's that? It's a special stick that has a special processor inside, especially for running neural networks. And what is interesting, that you can put several of them. You can use 2 or 3 of them in one application, and they will know how to run concurrently. And it's an interesting piece of hardware. Okay, and now we're getting how in the earth we run a neural network on something like this. And we are getting to the subject of our presentation. We're almost at the halfway mark. So it's OpenVINO. So let's state the problem that Intel is trying to resolve. There are a lot of deep learning frameworks widely used in the industry. Caffe, TensorFlow, Apache MXNet, and we see them growing like champignons after a rain. Like there are a lot. On the other hand, Intel is doing a lot of hardware. They are doing CPUs, i3, i5, i7, i7. They are doing graphical boards. They are doing Intel neural sticks. Each of them has different hardware capabilities. This is obvious, but they have a different instruction set. You need a different approach to take the most out of them. And for this, they've created OpenVINO. As an important remark, OpenVINO it's only for executing models. It's not for training. So I have a slide stalled from, and I'm going to share it now. Start from an Intel presentation from the which I found on LinkedIn. What they are trying to do, in the, let's say, usual normal way, you have the model, and you need to work all your steps, all your code, all your calling, all the optimization by yourself. With OpenVINO, you have the model. You run it through OpenVINO, which has a model optimizer, and you have an API to run it. This is in short. Again, this is from an Intel presentation. It's publicly available. So let's get the components step by step. As you see, there are two phases. In the phase number one, the model it's converted in one unified representation called intermediate representation. In the phase number two, intermediate representation it's run on the different devices. The phase one has three steps. The first step it's optimizes the model. It's taking the model from the various formats. It converts the format, optimizes, converts the weights and biases. The intermediate representation model, it's an XML, which is described the topology, and a binary file which holds all the weights and biases. Number two is doing the optimization. The model optimizes the model using different kind of techniques, fusion of layers, bechamalization, and more. It is doing a lot of hardware agnostic optimization. With the target of reducing the consumption of computation and memory. And it rearranged the data in memory looking to the device requirements at the second step. And third is does kernel level optimization. It will choose the right implementation for the instruction set architecture. At the third step, it format the models. The models are trained with weights that has a format of floating point 32, for example. But the devices sometimes can run faster with floating point 16, for example. This is usual for graphic processors from Intel, or an integer or something. The model optimizer can convert the format of the weights automatically per need. So this we did the model optimization. We take all the different models. We're talking about TensorFlow, Cafe, whatever. And the system took them, create 2 files, and then start running optimization of them. Optimization first, which is logical, doing something. Something that will make sense if you're, let's say, a bit of data scientist to understand what's happening. Second, it works a bit with the memory optimization, how it's aligned and stuff like this. And third, we choose the right architecture for the instruction set architecture. Last but not least, it looks at the model format, picks the right kind of floating number for your architecture. This is something that you do not need to, let's say, trouble your mind anymore. Afterwards, they give you an API to run this. This is the Inference Engine. This API, it's you have it in C++ and in Python, which is pretty enough of you have enough surface to do something. We have used the C++, and also we had discovered pretty decent Raspberry Pi documentation how to use it. Okay, now we are getting near the demo part. Let's try to explain you how do you get started with OpenVINO. So you need to install something. When you install, if you are following the step by step, you'll have 2 validation demos, and we're gonna play with one of them because it's pretty clear. First, let me explain you from where the models are arriving, because we are talking about models from the web, models from Intel has something called like a model zoo. So this is used in this in the validation of the OpenVINO installation. Also, you can use it in the application. And in the zoo, you have pre-trained models for a lot of stuff. Okay. How they decided to explain you all this stuff? They have absolutely good production. They have an Intel YouTube channel, and which you have good production. It's a bit let's say difficult to follow for me. I'm gonna start telling you from the example that it's installed with OpenVINO how you can get started. Okay, first in the model zoo. Not all the examples are, let's say, the models are not perfect. You're gonna see it. I did not, because I wanted to use the examples that are already in the setup used. I decided to avoid the one with the faces, and also to avoid problems of me telling a face in English, because that won't be that funny. So I use the registration plate model. So let me get us to try to share something else. In fact, I believe I can. Let's see. What can I share? I'll share is just on my. Let's see. So this is a batch file that runs an example. Okay, what they are doing here, they are um, running setup vars, which set up the environment variables that you can put also in your paths by yourself. Check for Python. Python is used for downloading the model Zoo, and in the steps of conversion, does the conversion of the model and all the stuff, and run it. This model can run on CPU, GPU, FPGA. This is logical gates and HDDL and Myriad. The last one are from Intel Neural Stick. Okay, if you are installed today at the end of May 2000 this, it won't work on CPU. There is a problem with the latest Windows update. They did not, there is a problem. But I'm guessing that in the next couple of days that will be solved. We'll get a new version of OpenVINO, and it will work flawlessly on CPUs back. Also, there is a problem in HDDL. HDDL and Myriad are two stuff that are run on Intel Neural Stick. The HDDL it's for when you need more performance. We today gonna try Myriad. I modified this sample in the manner that I'm using more picture, and you'll see the problems with the model. Let me try to share absolutely my screen because I want to share all the desktop with all stuff, not okay, whatever. Let's try it this way. So here you run it in this manner. You need to start to admit it. You have all the instruction in the instructions open one. So I'm still gonna try to share all my screen. All the desktops, whatever, because we'll have a couple of this takes, let's say, now it's downloading the model, it's doing the optimization, it generates a solution. If you're looking at the solution, it's a CMake file. It's pretty, let's say, convoluted. At the end of the day, it's not complex. You find the code, you can replicate the solution. Yeah, we did it. This particular solution will try to detect an out on the recognized number plate. If you are absolutely new to computer vision and to artificial intelligence generally, you should know that the models, they never gonna tell you that, for example, this is Catalin. If they look at a picture of me, you say that this is a probability of 80% that this is Catalin. So this, let me try to, okay, here we're gonna, it's loading this on the Intel Movidius device, and now I'm gonna share you the output of it, where it is. This one. You see, this is the one from the box. It's a black car, and it read the number. So when you close this application, the demo will continue. So I'll put it in front of me. We'll continue for the next picture, and I'm gonna share it. Well, we have something like 4 pictures. This, I've seen it running also without anything. This is now running in Intel, Intel Neural Stick. I'm gonna share this now to see what's the here. It's blank, and the picture is pretty good. I would say only the first picture was stock from Intel sample. Again, I close it, and now we'll run to another one. What I did not optimize, I should have put on the code of the device just there to run it on the new pictures. Now it's reloading the model on the device. The model is already pre-processed. Just loading on the device is the time that we wait. So we see this, again a blank. So moving forward. Now it's again, we have a couple of pictures more. And I have a point to make, and this is why we're running into through them. Again, this is, as you see, a good blank that we're gonna, and there are two more. So, now we got the number plate, but did not get the car. And we'll start getting successes. Again, the problem is not with OpenVINO, it's the problem with the model. And I'm gonna, let's say, spend a bit the time. Okay, let me show you this one. Here, strange enough, you see, it's in the number on the corner, not in the one in the foreground. And now will be the last one. Now I'm not showing you the output from the command prompt. It's pretty much the same. And this is the last one. Let me show you. Here, strange enough, it detects a white car, but no number. And getting back to the model, it says that, not the model, to the demo, it said that finished successfully. Okay, what's the problem with the model? The model was trained, and you find this also in the forums. The model was trained in China, and it looks for a blue number plate. Also, yeah, you can, there is a tool on Ubuntu to retrain this model, or also you can use your model. We have used our model, and it works. To try to get the stuff in the perspective. Again, somebody put very nicely the results of a similar test to what we have done. In a benchmark. They use a Raspberry Pi 4, we use a Raspberry Pi 2. So they have used Movidius, they have used Movidius is the old name of Neural Computer Stick. Now it's Neural Computer Stick 2. Movidius was the name of the startup that was eventually bought by Intel, and now it's moved around. What we see here, you see from NVIDIA Jetson Nano, and you see a lot of hardware they have tried. They have tried to run it directly on Raspberry Pi, directly on neural computer stick, running on computer Pro, MacBook Pro, on NVIDIA Jetson Nano several versions, and try to run the same model. Essentially, here the short bar are better. Generally, what you have seen here, it's how much money, that much music. How we gonna, you say in the Balkan. If you have a good hardware, you get better results. Our results are consistent with what we seen here. About our problem, how we have solved our problem with the screws. At the end, we run the model directly on the PC because we already had the PC, and we use the camera, normal HDMI camera. Okay, why did not we use OpenVINO? And because we took really the long hanging fruit. We were paid to do a weight counter, and we did a better solution. We needed to do a bit more investment in development to use that, and we get the performance was good enough. And let me tell you how lazy we were. We had a problem with the bluing. Some of the screws were blued, and the model was not performing. The normal solution to this, and the normal procedure of avoiding this, was first to do a filter, to do a black and white image, and then to do the image recognition. And we just took more pictures and retrained the model. That, let's say, that lazy we were. Also, to put more hardware like a neural compute stick, it in this case was pushing to the budget. So we had that much money, and that was the cheapest. And we did not need the performance more. We have some other solution, unfortunately, because by nature of our company, we are always working corporation. We cannot talk about it, and which we gonna use. That there is a difference in speed and in the price and in the hardware, in the resistance. I mean, but let's say the resilience of the solution, and on which the neural compute stick will help us. Also, on some other solution, gonna use just OpenVINO because the increased performance, which is in some cases significant because of the optimization and all the stuff, will help us go further. Okay, as let me show you. I'm gonna reach to my computer, and gonna show you this is what you see running. And if you do not believe me, we can try to run the same sample, and you'll see it that won't work anymore. But also it's a bit hot, and this is what we do the magic. Again, OpenVINO allows you not to modify significantly your code, to run a model to a lot of Intel hardware. And looking around, let's say I'm almost everything that's around me, it's on Intel. Okay, the phones, and they have there is an let's say an advantage. It's really an advantage of using OpenVINO. Sorry, no, so the optimization makes it worthwhile. In short, I said, if you want to get started with OpenVINO, just download it. It should work. If it does not work, wait for the next version. I discovered the problem 2 days ago, and from there it were 2 Windows updates. So they need a bit time. Also, there is on the forums. You'll be able to start playing on your hopefully Intel PC or something running. To create models, yeah, you have to create and train models. You have different options. As you have seen, it's not atomic science, and also the results are, let's say, at the end of the day, for us, it was a 99.9 solution to let's say, an interesting problem, ensuring that some worker puts the right number and the right kind of screws in something. It sounds mundane. And the solution, okay, if you say I'm using artificial intelligence and computer vision to solve this problem, it's laughable. But on the other hand, it wasn't expensive, it wasn't complex. Yeah, for us, it was a learning curve because, I'll say, we have a development arm and we have a hardware arm, and the people who are doing hardware are usually stuck in C, and they know everything about hardware, but for them, it's don't know. Daisy, something like this. And when they see all this stuff working, they say, okay, wonderful, let's do next. And they start throwing at us a solution. Even in time of coronavirus, we have developed a proof of concept of something. There is, let's say, I won't say it's a robot arm, that detects a face and points a thermometer to the face. So even for, again, it wasn't a huge development. We did not need something powerful like this. We use some PC, but still, using artificial intelligence and computer vision, it's something that you can start using today. It's not complex. It's rewarding in the way that you'll be able to do more for your customers. I'll say, my 2 cents, it's try it now. And I believe that we are at a bit past the time. So if you have a question, I'll look now at the chat. If not, put in the comments. We'll try to get answers as much as we can as we see them. So in short, this is it. Let's try it. Now you see, it's not that complex. Yeah, you find some strange stuff like a model train just in China and not living there. It happens. But you can do today a lot of stuff with this. Thank you very much, and I hope that you did not waste 45 minutes listening to me trying an impression of the of HAL from Odyssey 2001.
Thank you.
Thank you, Catalin, for the great presentation. We haven't got any questions yet, but normally, like, because we are like 60 seconds with the delay from the YouTube channel, so questions might come a little bit later. We also have someone from your country, and I believe from your city, Timisoara, joining us, Christian, which is nice. It was a really great presentation. I really liked.
Maybe they are from the people who are doing this, and they were afterwards called me. Yes, we did not say this, and you did not present this right. I said, guys, try to do my best. It's a nice stuff that you do here.
Great, awesome. So I don't see any specific questions yet, but later on we will keep an eye on comments coming in our YouTube channel, and we'll let you know if there's any questions we can get your answered over
also
there.
Subscribe to this channel.
Great.
I'm really mean it. Subscribe. You do not have any discounts to Amazon to anything, but it's a great channel.
Great, thank you, Catalin, and thank you for doing this at your night time. We'll leave you. You can have rest, go to bed now.
Thank you. I'm getting back to work. Have a nice day. Thank you very much. Hope
Great.
to see you soon.
Thank you. Thank you, everyone. Goodbye.